You know, we tend to think of our bodies as pretty stable, right? But on the inside, it's a completely different story. It's this incredible, non-stop balancing act just to keep us going. So today, we're going to dive into that amazing world of our internal chemistry. So let me ask you this. What is it, really, that keeps your heart beating, your brain firing off signals, and your muscles ready to move at a moment's notice? You might jump to thinking about, calories or energy from food, but the real secret is something way more precise, happening at a microscopic level.
And here it is. It turns out that literally everything, from a fleeting thought to lifting something heavy, all comes down to this incredibly delicate dance between the water in our bodies and these tiny electrically charged particles we call electrolytes.
Now, this whole process has a name, and it's a big one: homeostasis. This is the fundamental rule of our physiology. Think of it like your body's own internal thermostat, AC unit, and power grid all working together 24/7 just to keep everything in that perfect, just right zone for us to live.
And if homeostasis is the goal, then you got to think of electrolytes as the tireless, unsung heroes making it all happen. They're the ones carrying the electrical sparks, the messages that power our entire system from behind the scenes. So, before we can properly meet these key players, we've got to understand the rules of the game they're playing by. This is all about the basic physics that control how all this stuff moves around inside of us. Okay, first rule, osmosis. The one thing to burn into your brain about osmosis is that it's all about water. Water is always on the move, and it naturally wants to go where there's more stuff, electrolytes, sugars, proteins, dissolved in it. We call all that stuff solutes.
And then you have diffusion. This rule isn't about the water, it's about the solutes themselves. Instead of water chasing the stuff, diffusion is just the stuff spreading itself out. It moves from a really crowded area to a less crowded one until it's all nice and even.
And this really nails the difference, right? With osmosis, water is the thing that moves. It chases the solutes. With diffusion, the solutes, the stuff in the water, are what move. They just spread out. One chases, the other spreads. It's a simple idea, but it's absolutely crucial for understanding everything that comes next.
But what happens when the body needs to break the rules? What if it needs to push solutes from a less crowded place into a more crowded one? Well, that's where active transport comes in. It's like a VIP door that uses energy to open. Think of it like a bouncer at a club, specifically letting certain electrolytes in, even if it means going against the natural flow of the crowd.
All right, we know the rules of the game. Now it's time to meet the star players. We're going to talk about the big three electrolytes and the absolutely critical jobs they have inside of us.
First up, we have sodium. This guy's the absolute manager of your brain and nervous system. It controls nerve impulses, cognitive function, pretty much the entire neurological show. So from now on, when you think sodium, I want you to immediately think brain.
Next, meet potassium. If sodium is the grain manager, potassium is the conductor of the orchestra for your heart and your muscles. It's responsible for the electrical signals that keep your heartbeat steady and strong and that allow your muscles to contract. So think potassium, think heart. And then there's calcium. Now, we all know it's a builder, right? It makes our bones and teeth strong. But it's also a crucial messenger. It plays a huge role in things like blood clotting and sending signals inside our cells. So it's both a builder and a communicator, which is pretty cool. Now look at this. What is absolutely wild here is just how tiny these normal ranges are. Don't worry so much about the specific numbers, just look at the window they operate in. For potassium, a healthy range is just from 3.5 to 5.0. That's it. Any little nudge outside of these super precise windows can cause huge problems. It really shows you that in our bodies, balance is literally everything.
Which, of course, brings us to our next question. What actually happens when that delicate balance gets tipped? Let's take a look at the real-world consequences when these critical electrolytes go too high or way too low.
So, let's start with our brain manager, sodium. Because its main job is running the nervous system, it makes sense that any imbalance, too much or too little, is going to show up first as a neurological problem. The brain is where you'll see the first signs of trouble.
So when sodium gets too low, a condition called hyponatremia, the brain can actually start to swell with excess water. This can lead to things like confusion, serious memory issues, and in the worst cases, seizures. And that's exactly why, for a patient with low sodium, the #1 priority, above all else, is keeping them safe.
Okay, now for our heart conductor, potassium. And just like sodium problems show up in the brain, potassium imbalances show up directly in the heart's rhythm and its ability to function correctly.
This quote really says it all. When potassium gets too high, a state called hyperkalemia, it messes with the heart's very precise electrical system. It actually changes the electrical charge of the heart cells, making them super unstable and likely to fire off chaotically. And that can lead to some really dangerous, life-threatening heart rhythms.
And here's the cause and effect. High potassium is often the result of something like kidney disease, where the body just can't filter it out properly. The effect? Well, you get things like muscle weakness, and you can see really dangerous changes on an EKG, which is that test that measures the heart's electrical activity.
So, since these imbalances are so dangerous, how can we spot them? For our last section, let's play detective and look at how we can decode the body's messages to figure out what's really going on.
Let's start with the fluid part of this whole equation. What are the main signals that tell us someone is getting dehydrated or maybe has way too much fluid on board?
Here are 3 really great checks. First, a high urine-specific gravity. That's just a fancy way of saying the urine is really, really concentrated, which is a classic sign you're dehydrated. Second, a lab value called BUN can be elevated, which also points towards not having enough fluid. But you know what the most reliable indicator of all is? A simple daily weight. Seriously, it is the gold standard for tracking whether someone is gaining or losing fluid.
So what's the big takeaway from all of this? It's that deep down inside all of us, there's this invisible, constant, and incredibly delicate balancing act going on. And it's this precise equilibrium of fluids and electrolytes that makes everything, and I mean everything else, possible. Every single beat of your heart, every thought that crosses your mind, every little movement you make, it all depends on this balance being just right.